Hydrogen is having a reducing power like alkali metals. They can provide one electron, they can remove oxygen from the metallic oxides. Burning hydrogen burns in oxygen to form water. With the pop sound, alkali metal also reacts very vigorously and they react with oxygen to form their respective oxides like lithium oxide, sodium oxide. We'll check their formulas are also very similar. Now, combination with non-metals like alkalis, they react with oxygen, sulfur, and chlorine. Similarly, hydrogen is also reacting with oxygen, sulfur, and chlorine. So, now coming to the similarities of hydrogen with halogens. They all have one electron in the outermost shell, shortage of one electron in the outermost shell. If they are provided, if they gain one electron, they will acquire a noble gas electronic configuration. Valency is 1 because they gain one electron, formation of ions. When they gain electron, they get converted into negative charge anions. Hydrogen H minus, chlorine also Cl minus. Electronegative character, both halogen and hydrogens are non-metal, so they get negative charge on them, so they show electronegative character. Physical state, if we check, chlorine, fluorine and hydrogen all are gases. If we talk about atomicity of hydrogen, chlorine all is 2, H2, F2, Cl2, Br2 and I2. Now coming on to second, there is difference also, not similarities. Hydrogen does not have similar property with alkalis or halogen. There are some dissimilarities also. Hydrogen atom has only one shell, whereas alkalis and halogens have two or more than two shells. Oxides of hydrogen is neutral, whereas oxides of alkali metal are basic and that of halogens are acidic in nature. Now, who discovered hydrogen? Henry Cavendish was the first, then Robert Boyle, then Lavoisier in 1783 gave it a name. Hydrogen means water former. Hydrogen is found in free state or in traces in earth crust or atmosphere. Volcanic gases also contain 0.025% of hydrogen, and sun and other stars have a large storage of hydrogen. In combined state, hydrogen is found everywhere, plant, animal tissues. They are made up of compounds of hydrogen and carbon, oxygen and nitrogen. Hydrogen is the characteristic constituent of all acid, bases, alkalis, hydrocarbons and proteins. Even water contains hydrogen in large amount. How to prepare hydrogen? Hydrogen can be prepared by reacting metals with acid, metals with water, and reactivity, if we say different metals react with different conditions with same water or with acids. Let us see the reactions of metal with water. Sodium, potassium and calcium reacts with cold water and the reaction is very fast. They form their hydroxides and hydrogen gas is coming up from there, and these reactions are exothermic reactions. If you talk about potassium, when piece of potassium and sodium are added in water, they form a globule dart. They start moving. Silvery gray globule is being formed, start moving, large amount of energy is given, and vigorous reaction. Even it catch fire. Potassium forms a lilac color flame, whereas sodium, when sodium is reacting with water, it forms a yellow flame. Both of them, sodium, potassium, are floating because they are lighter, the density is less than that of, and the reaction is very vigorous and exothermic reaction is taking place. Sodium, if we are using sodium or potassium, the reactions are such that we need to control them. The reactions are very fast. Sodium amalgam, an alloy of sodium with mercury, and potassium amalgam, the alloy of potassium with mercury, they can be used to produce slow reactions. So hydrogen can be safely prepared from these amalgams. If with directly using its explosive reactions. Reaction with calcium. Calcium is heavier than water, so it sinks. Reaction is less vigorous as compared to sodium and potassium. They form alkalis, calcium hydroxide and hydrogen gas is liberated. But after some time the solution turns turbid and we can test the solution of sodium, potassium and calcium. It turns red litmus blue. means all of them forms a basic solution. Okay, now action of hot water on metal. All the metal don't have same type of reactions with water. Magnesium does not react with cold water, so it is reacting in what condition? It is either reacting with boiling water or it is reacting with steam. With boiling water forming magnesium hydroxide and hydrogen, with steam it is forming magnesium oxide and hydrogen. Now let us see the reaction of aluminium. If we talk about aluminium, zinc and iron, they don't react with steam. These elements are further being first heated or boiled in water. When they become hot, then they react with steam. Aluminium reacting with steam at 800 degree, forming aluminium oxide and hydrogen. If high temperature is not being used, aluminium will form a coating which is difficult to remove. So we have to put aluminium in boiling water to remove that layer. Zinc even is less reactive, it only when reacted when it is heated and then steam is passed over it. Then will form zinc oxide and hydrogen gas. All the metals, when they are reacting with steam, they will be forming oxides. If they are reacting with cold water or warm water, they will be forming hydroxides. So in this reaction, when zinc oxide is formed, which is yellow in color, and when it is cooled down, it changes to white. Reaction of iron. Iron is less reactive than zinc. So iron is first heated to red hot. Iron is heated to red hot and then steam is passed over there. So iron plus water gives triferric tetraoxide and hydrogen gas is given. If hydrogen or this Fe3O4 is not removed, the reaction is carried out in a closed container. It is a reversible reaction. We want to summarize that when a metal reacts with steam, rate of reaction is fast in case of magnesium. But as we go to aluminium, zinc and iron, the reaction decreases. In case of magnesium, aluminium, zinc, reaction stops after some time because oxide layers are formed if they are not being allowed to react with steam. So they do not further react, hence the reaction stops. So there are conditions which will be followed. Now coming to another action of steam on non-metals. When steam is passed over red hot coke, water gas is formed.